Okay, so this problem, it looks difficult, but you'll see it won't turn out that bad. First of all, we're being raised to the 1/3, or in other words, the cube root. And so here we have, on the numerator we have a power of 1, and then in the denominator, you look at it as 4 times 1/3, or 4 divided by 3. So the highest power is 4/3. So that's what we're going to divide the numerator and the denominator by. Okay, so let's do that. So we're going to have 4x minus 9. And then in the denominator we're going to have 3x to the 4th minus 2 to the 1/3. Okay, so divide by x to the 4/3. 4/3. And then here we're going to divide by x to the 4. And I'm going to write this one a little bit differently just to save myself a step. Instead of writing it as x to the 4/3, I'm going to write it as x to the 4th raised to the 1/3. And this is the same by the laws of exponents. Okay, now here these simplify, and I'm left with x to the 1/3 in the denominator. And now these, well, these have the same exponent, so I can bring the x to the 4th inside without a problem this time. Okay, so here I have the limit as x goes to negative infinity. And notice that this time the sign doesn't matter, because when you raise a negative number to the 4th power, it's always going to turn positive. So you don't have to worry about what we had to worry about in the previous two problems. Okay, so we have 4 over x to the 1/3 on top minus 9 over x to the 4/3. And then we have 3x to the 4th over x to the 4th minus 2 over x to the 4th. And all this to the 1/3. So all I did was bring the x to the 4th inside. Okay, now these guys cancel. And so this guy's going to 0, this guy's going to 0, and this guy's going to 0. So that means that we have 0 over 3, which is the only thing that's left over, to the 1/3. Well, this is just equal to 0. Okay, so this involves a trig function, and limits involving trig functions generally are a little bit trickier, just because you have to know a little bit about the function itself. Now here it says that x approaches pi over 2 from the right side. And we have e being raised to the tangent. Now we know that tangent of pi over 2 is undefined, but that's because there's a vertical asymptote at pi over 2. So if I draw a quick sketch of tangent, let's say this is pi over 2, negative pi over 2. So tangent looks something like this. And then it repeats itself to the next vertical asymptote and such. And so if we approach pi over 2 from the right, well, tangent is going down to negative infinity. So really what we're looking at is e being raised to a really, really, really big negative number. Now obviously this isn't technically correct, because infinity isn't a number, so you can't really plug it in, but what you're imagining is a very big negative number. A very big negative exponent. Well, negative exponents, to make sense of them, we have to turn them positive. So this guy is the same as 1 over e to a very big number. And e raised to a very big number is simply a very, very, very big number, and so the denominator is getting bigger and bigger and bigger, so this guy is going to 0. And so the answer is 0. Okay, so this is the last problem in our handout, and it deals with an infinite limit again. And so what we have, the same type of a deal, we're going to divide by x to the highest power. So the highest power is, in this case, just x, because x cubed divided by 3 is x. So I'm just going to rewrite this, and I'm going to do this in one step, because we've done several of these already. So I'm just rewriting this again. Okay, so I'm going to divide here by x on the numerator. Then the denominator, I want to bring it inside, so remember you have to think of what's going on. So you have to say that x is equal to the cube root of x cubed. Now this is true, but you have to be careful with the sign here. So these guys, these x values, since x is going to negative infinity, these guys are negative. And here, well, if you have a negative number and you cube it, well, that's going to be negative. You get the cube root of it, it's also going to be negative. So this time you don't need to put a negative sign in here because these guys match. And that's different from the other ones we've seen. So that's important to realize that in this case you can just bring in the x cubed without a problem. Okay? Alright, so now we simplify. So these simplify. This guy is going to go to 0. These guys simplify, and this guy is going to go to 0. Okay, so what we have here is 1 over the cube root of 9. And that's it.